district heating. So in 2016, the Paris Agreement was a historic moment where 185 countries, sorry, can you hear me, ratified the agreement to keep the temperature rise globally to 2 degrees, or maximum 1.5 degrees. So what? What does this mean? Well, actually, there's a lot of work that needs to be done to actually achieve this. It's all very well, but how will this huge task actually be achieved? So all countries will have their own targets and strategies that they're working on. In particular, the UK has one being to achieve net zero CO2 emissions by 2050. But I want to ask, in a country so heavily reliant on gas boilers, how will our homes be cleanly heated by 2050? An alternative to the conventional gas boiler is solar photovoltaic thermal, PVT. This is a promising technology for cities in particular, since it produces heat and electricity in the same area, so it's good for high energy dense areas. And with 70% of the world's population projected to live in urban-like areas by 2060, I am investigating how to cleanly heat our homes in the future cities. So my research question is, what opportunities are there for PVT and storage district heating systems? Now, I say PVT and storage because this is an area that hasn't really been looked into in literature. There are PVT studies, but PVT storage with district heating is an uncharted area of research. So I ask myself, Anneka, how are you going to do this? Well, I will model a home in a building simulation tool such as Energy Plus. And separately, I will model the PVT and storage systems in a system modeling tool such as Demola Medallica, an object-oriented modeling tool. And I will co-simulate these two systems together to get them to talk to each other so I can see how the system and the building are interacting together. And with this model, I'll be able to try out different buildings and different scenarios, change the system parameters, and try out different configurations to see what kind of results I get. And to put this into perspective, I will be using 3D digital maps, which I will have access to for some London boroughs, so I can see what potential there actually is in the real world, and at what point does it become economical according to the population density or the roof area, for example. So what is the point of this? Well, first of all, I want to see how much CO2 emissions can be reduced in the domestic sector. From a systems engineering point of view, how does the storage and PVT system interact together? Is it economical? Is it feasible in terms of the installation costs and the outputs you're getting? And finally, I hope to contribute to government policies and strategies, especially on their heating strategies for 2050. Thank you.
Anneka, thank you. Apart from CO2, do you have other criteria for your optimization or evaluation?
Yeah, so what would be interesting is to see how much heat or electricity certain areas need, because I'll actually have access to the energy data of certain areas in London as well. So to see how much heat and electricity the PVT system can supply. Also, it's interesting to see how grid dependent the system is. So whether the PVT system can cover all of the demands and how much electricity you still need to buy from the grid. Again, that will weigh up the economical factors that need to be taken into account. There's also other factors, it's quite complex, but like ownership of houses, and what kind of areas this could be installed in. So there's already some kind of similar projects for ground source heat pumps, and that's particularly done on social housing. So that could be another route to look into, and new housing. So it's, yeah, there are a lot of other factors. It's not just CO2, it's like how easy is it to install and how viable is it compared to other viable solutions that there could be.
Anneka, what is your background? Is it civil engineering or electrical?
Mechanical.
Mechanical engineering, okay. I have a feeling that you may be tackling a topic that may be far too, far-reaching, in a sense that you need to look also the grid, you need to see not just a case study of a district, but also the city's grid. So are you in a position to handle that, or is it just a data study, more or less?
Yeah, you're right. It is quite a broad topic, but I am going to be focusing on the thermal performance of the PVT system and how that interacts with different houses and it supplies the heat. I will be touching on the grid, but actually I can look into inverters. I used to work in the electrical storage industry, so the inverters already have a lot of control in that to direct the electricity to the grid or to the home or to the battery. So I can just take that control that's already there from the inverter and put it into my system. So hopefully I won't actually have to be designing controls myself. I can just take what's already there and implement that.
Because, I know, for instance, in our country, where photovoltaic cells are really high in use, they don't allow citizens to install batteries in their houses to directly use the solar energy. Everything has to go to the grid, and the grid, the company that handles the grid, cannot accept multiple, connections and usage. So it's really complicated.
Yes.
So that's why I'm asking.
Yes, that is true, because also I know you can get problems with overloading the grid if you have too many installations in one area. So yeah, that's a valid point that I will have to consider.
Very interesting topic. I don't have background in energy modeling, but what looks interesting to me is because you're largely looking at what-if scenarios, and until 2050, that's a long way to go. Just from my hunch, I think if you compare it to ground source heat pump, which is below the earth, so the factors, external factors that would influence PVT, like skyline, orientation, and many other factors would come in. So how would you model, how many parameters are you actually going to deal with? Are you going to look at the skyline, access to the building profile against the neighborhood, and how would that be incorporated in the model?
Yeah, so are you asking how will the 3D digital maps
Right, and
be
so for
used?
example, let's say, where you're located, and the skyline would influence how much access to the,
Yeah, okay.
sun and, yeah.
I do use roof area for one thing. That's one of the physical parameters I can put into my model. But also the benefit of having access to the 3D digital maps is that I can see the volume of the buildings, and I can scope out any potential communal storage, because as you say, yes, a lot of people won't want to have a battery in their small flat or hot water tank. So the reason why I'm looking at district communal storages is because there's more potential for people to be more willing to have a communal storage area, and it's probably going to be more viable as some pilot studies have already done in the UK. Yeah.
Thank you very much.
Thank you.